Hello students, welcome to Sreenath. In this video, we are going to discuss the 13th chapter, which is motion and time from 7th class science students. Okay, so my name is Karthik Nune. We are creating videos on all subjects from class 6 to class 12. So please do subscribe our channel. Also like and share our videos, students. Let's begin this video. So now what is our chapter name? Our chapter name is motion and time. Motion and time. So in this print chapter, we are having 5 topics, students. So we are going to have the overview of all the chapter. After that, we will discuss each topic in detail. So without wasting time, we are going to discuss we are going to have the overview of a whole chapter, students. Now motion and time, this is the chapter name. So basically we have learnt we are going to discuss, we are familiar with the word called motion and time, but we are going to know something new in this chapter about motion and time, students. So first topic is slow or fast. So we are frequently using this word slow or fast, but whenever the objects are moving fast or whenever the objects are moving slow, so how can we decide which object is moving fast or which object is moving slow? On which basis you are going to deciding it? So that's what we are going to learn it, students. That is on the first topic. And the second topic is speed. We know that speed, we always use speed. While we are riding a bike, or your parents or any elders are riding a bike, you always ask them to go speed. We have to move faster. We have to win the race, like that. So while comparing with other riders, while comparing with other buses or vehicles, we have to move fast. We have to move speed, and we have to reach our destination fast. That type of words you will talk now, students. So the next third topic is measurement of time. So how we will measure the time? Basically we know that we will measure the time using clocks. So how the time is measured in the olden days, that's what also we are going to learn, students. Okay, next thing is the units of time and speed is the subtopic of that measuring time, students. Next, fourth topic is measuring speed. So how we will measure the speed? So that's what we are going to decide, students, and that's what we are going to learn. And the last and most beautiful topic is distance time graphs. So we know we are going to learn about graphs and distance and time graphs. So what is the use of distance and time graphs? We are going to know that also, students. So that is all our present chapter, students. That's it. Here our chapter ends. So this is the whole overview of the whole chapter, students. So without wasting time, we have completed our overview. So now we will going to start each topic in detail. So now we will start our first topic, students. What is the first topic? That is slow or fast. So these are the familiar words, students. So some vehicles move fast. At the same time, some vehicles move slow. At the same time, while there is only one vehicle which there is such vehicles which can move fast, and at the same time which can move slow. So vehicles. So a vehicle can move fast, and at some other time it may move slow. And some vehicles move fast and some vehicles move slow. What are the examples of the vehicles moving fast? That is like aeroplane which will move very fast. No. What is the vehicle which is moving very slow? That is bicycle. Bicycle which will go very slow, which will move. This is the fast and this is the slow. And normally comparing aeroplane and bicycle, aeroplane is the fast, students. Comparing aeroplane and train, aeroplane is the fast. Comparing the train and the bicycle, train is the fast. Okay, students. So what happens is this bicycle moves slow when compared to other vehicles, students, and this aeroplane will move very fast, students. So there is a train now. So it can move very faster when compared to some vehicles, and it can move slow also. And sometimes whenever it is reaching the railway station, it will move slower. But whenever it is leaving the railway station and it will accelerate, it will move faster, students. So basically how did you decide which object is moving slow and which one is moving fast? So on what basis or how you are deciding that which object is moving fast or which object is moving slow? So if you want to decide which object is moving fast or which object is moving slow, we can easily do the task whenever the vehicles are moving in a straight line. If the vehicles are moving in a straight line in a same direction, then we can easily say which vehicle is moving fast or which vehicle is moving slow. Suppose this is the picture, this is the picture of the vehicles on a road. After some time, this is the picture of the same vehicles on the road. Can you observe which vehicle is moving fast from these two pictures? I am giving you 3 seconds of time. You have to give that answer, students. So 1, 2, time's up. So if you clearly observe, this is the green car, so which is very moving fast. So why? Because means in this picture it is in the middle of the all the cars, but in this picture it will crosses, it will come so front of all other vehicles. So comparing with other vehicles, this green car is moving, students, moving fast, students. So okay, students, and there is an activity, if possible you can do, students. So what is that activity? That activity is nothing but these are that based on this picture. So which vehicle is moving the fast of all? Which one of them is moving the slowest of all? Where I have answered this question, which one is moving fast? So you have to answer the question of slowest. So clearly observe this picture. This is in your textbook, and find out which is slowest of all vehicles. Okay, students. So the distance moved by objects in a given interval of time can help us to decide which one is faster, slower. So how can we decide which one is faster, which one is slow? In that discussion, if they are moving on a same direction on a straight line, we can decide easily. And how we are deciding is, if you know the distance traveled by that vehicle in a given interval of time, then you can easily decide which one is moving fast. So basically all these vehicles are there. We have given some time interval, and after that time interval, you have to, if you measure the how much distance they have moved from this place to this place within that time interval. Suppose you have given them suppose 5 minutes of time, you have given them 5 minutes of time. So before 5 minutes all these vehicles are there, after 5 minutes all these vehicles are there. Now what you have to do, you have to measure the distance of all vehicles. So in that time interval, so which covers the large distance, then we say that is the fast thing. We say that is the fast, that vehicle is fast. So in this time interval, that is 10 minutes, which covers the small distance, which moves the small distance, we say that is slow, that is moving slow. That's it, students. So now you can also decide whether decide by doing a practical example also. Suppose you are at bus stop and your friend are at bus stop, and both what happened, you started your journey to the school by bicycle, on a bicycle, and your friend is coming to your school on bus. So both are started at the same time. Okay, and after 5 minutes what happened, your friend has reached your school in bus, but after 5 minutes you didn't have reached your school. We have covered some distance. So the time interval, in the time interval of 5 minutes, how much distance your friend has covered? So he has covered all the distance. So total distance from your school, from your bus stand to school, but in that time interval we have covered some distance only. So basically how we can, then which one is moving faster, whether you or your bicycle or your friend is moving fast? So basically your friend is moving fast. Why? Because the bus which is moved fast. Why? Means it has traveled large distance in the 5 minutes of time, but your bicycle is not traveled that much of distance, it has traveled small distance in that 5 minutes, students. So which objects are covering large distance in given interval of time are the fast? So finally how can we decide it? This means objects which cover large distance in given interval of time. Are moving fast. At the same time, objects which cover or which travel small distance. Here I am mentioning large distance, small distances, but we are mentioning large and small means by comparing between two things, students. So whenever we are comparing with the your bicycle, that bus is moving fast, so that bus is covered large distance. That large word means it is compared, whenever it is compared with the distance moved by your cycle. And this is smaller means the smallest distance means that it is smaller. Why? Because means it is compared with the distance traveled by your bus. Okay, students, that is the thing you have to remember. Objects which cover small distance in given interval of time are moving slow. So in this way you can decide which is faster, which is slow. That's it, students. One more thing is, suppose in the case of 100-meter race, so this is the first thing. So this is the A. In this way also you can decide. What is the another thing is, suppose there is a running race competition. So in your school also, sometimes on the occasions of Independence Day or some Republic Days, on some days, what they will do, our school will conduct some of the games and some of the running races and kabaddi and kho and shuttle badminton, like that games. No, so on that occasion, if you see that there is a 100 meters running race, so in that cases the distance is fixed. Here what we have said that the law which in the given interval of time which cover the large distance is the speed, which they are the speed things, okay, in the given interval of time. So but in this case 100 meters, so distance is fixed. So in this case, how you will decide which is moving fast or which is moving slow? So the 100 meters running race is there, and all the athletics or all the students are participating in that running race. So whenever the running race program or the game has started, all are started running. So one goal has reached the target in 20 seconds, and another boy has reached the cover the 100-meter distance in 22 seconds, just example, and another has reached about it 23, and some other set 24 seconds. So in this case, distance is same, 100 meters distance. They have covered the 100 meters distance. One goal in 20 seconds, another boy in 22 seconds, all are the remaining others are 23-24 seconds, like that. So in this case, how you will decide which goal or which boy is moving fast or which is slow? So this is so simple, students. How? Because means basically in the previous case we have decided by comparing the distance, how much distance they are traveling. So in this case time is constant, time is fixed. So whenever time is fixed, so which will cover larger distance is the largest speed. So in this case what happened? In this case distance is fixed. So in this case, how you will decide which is moving fast or which is moving slow? So this is very simple, students. So whenever here time is fixed, we decided by distance, which will cover large distance is moving fast. So whenever distance is fixed, we will decide it by time. So who or which is covering this distance in short time are having more speed. So basically this goal is covered in 20 seconds, this boy is covered in 20 seconds. So who will get the first prize in that competition? Obviously the 20 seconds. So the girl who completed this distance in 20 seconds will get the prize, first prize. Why? Because means he is having high speed. Why? She is moving very fast, so she is fast among all other those, so she is moving fast. they are moving slow. How we have decided means she has covered the distance in short interval of time, less time. He has taken more time to cover the distance. So in this way, whenever the distance is fixed, we are going to decide it by time. Simply, whenever the distance is fixed, we compare it by distance. Distance is large. Whenever it covers large distance, they are fast. Whenever they covered small distance, they are slow. So simply in this area, whenever the distance is fixed, we are compared by time. How much time taken? Time taken. We can write it as time taken. So if who is taking less time is fast. So to cover this distance, who is taking less time? That person or that thing or that object is moving fast. So who are taking more time or high time or moving slow. Here also students, I used the words of less and more. So less and more means how we are decided this is less time is when compared to remaining times, we are decided this time as the less time. And how we have decided more time is when compared with other times, all the 20 seconds, when compared with 20 seconds and 2 seconds and 23 seconds, 24 is the highest of all. That's why you have decided here more time. So that who are taking more time are which means who are moving slow. Who are taking less time to cover distance means which means who are moving fast. So these are the two things students. Whenever the time is fixed between two positions, then who are covering larger distances are moving fast, who are covering less distances slow. Whenever the distance is fixed, we are going to decide it by time. Who are completing it less time are moving fast, who are completing it taking more time are moving slow. That's it students. That is the fast and slow topic students. I hope you have understood it. So our first topic is completed. Okay students, now we will discuss the second topic. What is the second topic? That is speed students. So this is the word you are familiar with while we are in journey, while we are riding. So we will like to go speed, we will like moving speed, ride speed. Okay students, so this is the most familiar word students. So how you will decide? So a higher speed seems to indicate that a given distance has been covered in a shorter time or a larger distance covered in a given time. So whenever we are moving fast, it says that our speed is high. So whenever we are moving slow, it says that we are moving slow. So how we will decide whether we are moving fast or we are moving slow is it is based on speed. If speed is high, we are moving fast. If speed is low, we are moving slow. Speed is slow, speed is small, then we are moving slow students. Okay, so in which conditions we are having higher speed means whether if you cover the given distance in a shorter time, like means this in the 100-meter race, that girl has covered the distance in 20 seconds, so she takes lesser time. So if anyone covers the given distance in shorter time, then in that case we say we are having high speed. Or another case, or a larger distance covered in a given time. Suppose if some time is fixed, in that some time if you cover larger distance, in that case also we are saying that our speed is high, we are moving very speed. So and the most convenient way, who is moving speed, who are moving speed means, so basically if time is fixed, who are covering large distances, he is having the speed students. So that is the most familiar way students. Okay, suppose we call the distance covered by an object in a unit time as the speed of the object students. So if you want to decide distance or the speed of the two buses, if you know the distance covered by them in 1 hour of time, then we can easily decide the speed of those buses and which is moving fast or which is moving slow, or which is having high speed or which is having low speed students. So suppose if you have seen that our car, suppose our car is moving at 50 kilometers per hour, what does it mean? What does that mean? Means its speed is 50 kilometers per hour, which means it is covering 50 kilometers in 1 hour of time. So in 1 hour of time it is covering 50 kilometers, students. That is the information from speed 50 kilometers per hour. So whenever you are seeing that 60 kilometers per hour means if you are go at that speed, you will cover the 60 kilometers of distance in 1 hour of time, students. Okay, so basically whenever you have given that whenever you are talking about 50 kilometers per hour and our speed is 50 kilometers, or car speed is 50 kilometers per hour means, so in that case what you will think, does you always move from the start, from the beginning of your journey to the ending of journey with the same speed, with the same 50 kilometers per hour? Yeah, obviously it is not the same. So whenever you are starting your bike or the vehicle, it will move very slow. It will start from 0 speed and increases its speed and increases its speed up to maximum. After that, whenever there is a traffic, or whenever there is objections, or whenever there is any obstacles, you will apply brakes, then your speed will decrease, and after that again you will pick up your speed, and again you will decrease your speed. So in the whole journey from the beginning to the ending, what happens is your speed is not fixed. Your speed is not 50 kilometers per hour through all the journey. So it is undergoing fluctuations. At some time it is 0, at sometimes it is increasing, at sometimes it is 50, at sometimes it again decrease, again increase. So that fluctuations in your speed you will observe. But here we are saying that 50 kilometers per hour is our speed, which is the average speed. It is not the speed with which you have traveled from beginning to the ending. So that 50 kilometers per hour, that speed is the average speed. Average speed you have traveled throughout your journey. So don't think that 50 kilometers per hour speed means at any point on the journey, at any point of time on the journey, you have moving with same 50 kilometers per hour. So it's not the thing, students. Okay, so you will have your speed will be increased or decreased. So in that case what will you do is you will find the average speed. How you will get the average speed means, average speed is nothing but the total distance traveled by the total time. How much distance we have covered in how much of time. So by dividing both you will get the average speed. So in this chapter we will use the term speed instead of average speed. We will take both are same. So what is the formula for finding the speed? Means basically it is the total distance covered. So how much distance you have covered by the total time, how much time you have taken, total time. So whenever we are dividing both these values, you will get the speed of your journey, or you will get the how much speed you are going. So suppose if you are moving, suppose you have started at your home, okay students, and at that time here 0 seconds, and you have reached the school. It takes almost 60 seconds, like that. It will takes more than 60 seconds. I will write something as 360 seconds, like that. So what is the total journey from house to school? Suppose how much distance it is. Suppose it is 720 meters. So if you write it in kilometers, 720 meters the distance, which is less than 1 kilometer. Basically I want to tell you one thing, students. 1 kilometer means how many meters? That is 1000 meters. 1000 meters, students. Suppose this is the 720 meters. This is the distance from your house to school, and the time taken for you to from house to school is 360 seconds. Then what is the speed? Speed is nothing but the total distance, that is 720 meters divided by 30 seconds. 300, that is 360 seconds. So this is in meters. So this is in seconds. So how much it is? 362. So speed is 2 meter per second, students. Sir, what it is? This is in meter per seconds. But in our daily life we will use always kilometers per hour. No, yes, kilometers per hour. Suppose if you take that time taken from your house to school or any picnic spot, I will keeping those things 0 seconds, 360 seconds. I am writing here. Suppose from the school we have went to a picnic spot. So in that picnic spot, how much distance it is? Suppose it is a distance of 30 kilometers. So how much time it takes? Approximately it has taken for you 1 hour. 1 hour to reach the picnic spot. Then what is the speed in this case? Speed is nothing but total distance. How much distance is there? It is 30 kilometers divided by total time. What is the time taken? Here it is in kilometers. Time is 1 hour. So that is 1 hour. So how much it is? 30 divided by 1 is 30. So 30 kmph, students. So this is the favorite. This is the thing you will see in the case of speedometers, in the case of bikes or vehicles, students. So what is the speed of your journeys? What is the average speed of your journeys? 30 kilometers per hour, students. So one more thing I have to tell you is you can find out the speed of you also. So suppose if you are moving from one place to another place by walking, you can find out the speed of you also. How we can speed? Or you and your friend have a bet of something, who will reach the distance. Then if you want to know whether I am having high speed or whether my friend is having high walking speed, for that you have to know the distance between two places, where from where to where you are going to, so you have to need just a distance between 2 points, and you have to start at these points, and you have to note the time. So you have to both you and your friend has reached the destination. So after reaching, you have to measure how much time you have taken, and suppose you have taken 10 seconds and your friend has taken 20 seconds. So you have noted the time, and you have know the distance between 2 points. Then dividing the distance with the time, you will get the speed. So by that you can say, so I am having you can say I am having good speed, or I am having less speed, like that, students. Okay, students. So that's it, students. That is our second topic, speed. Okay, students, we will going to learn about the measurement of time, which is the third topic, students. What is the third topic, student? That is measurement of time. So we are familiar with the word called time. So how we will measure the time? So then you will say, sir, we will measure the time with the clocks and with the watches. And nowadays, sir, we don't need watches, sir. Why? Because we are having time in the cell phones, or we are having time in the TV screens, or we are having the time in railway stations, or everywhere there is time. So we don't need watches like that, sir, to measure the time. So that is the updated technology, sir. Yes, I will agree with you, students. Nowadays time is everywhere. Even though we are not using the wrist watches or the normal watches, dial watches like that, so many are using smart watches. Through that smart watches, you can easily find out the time. In this case of this dial watches, you have to see and you have to measure. So the hours mule is there nearly 4 or like that. So minutes mule is minutes hand is like that. So we have to measure. So this is 4:23 like that, 4.5 hours like that. But in the case of smart watches, there is it will directly project you the what is the present time. Simply by seeing the smartwatch, you can get the digital time, that is 4:20, or it is 4 hours 20 minutes, or that is 3 hours 30 minutes, like that, simply. So so these are like digital clocks. These are the digital clocks. So now present generation is running on digital clock, students. Okay, so how we will measure with the time? Basically, how we will measure time is by watches. There are wall clocks, there are table clocks, there are digital clocks, there are watches, wrist watches, and that wrist watches also there are upgraded watches. So all these measures the time. So okay, this is the present generation situation. But so in the present generation, we are using digital clock, digital watch, digital clock or watches or anything. So this is the present generation situation. Okay, I will agree with you. But what about the past? Whenever there is no watch, whenever there is no digital smartwatches, whenever there is no computers, whenever there is no mobile phones, whenever there is no communication, in that old days, how they measured the time. So that's what thing, that is the thing you are going to learn now, students. So in that case, what are the methods our ancestors are using to measure the time is basically they are the greatest ones. Why means by seeing this digital clock we can easily find out the time. It doesn't take that much time. It is a very simple matter, but in the olden days they are very great and they have used their brain so much so that to find out the time trends. So basically how they have find out the time. So by looking the shadows and by looking the sunrise. So by looking the shadows, by looking the shadows, by looking the moon, by looking the sun, by looking the sunrise and sunset, and by looking the motion of the sun, they are measured the time trends. Okay. So by seeing the sunrises and sun setting and by seeing the moons also, they will measure that why if there is one sunrise and one sunset, then you will say that one day is completed. So whenever there is sunrise, that there is a next day started, like that, students. So and how they have measured the months. So basically by observing the moon, they have measured the months. For by observing the sunrise and sunset, they have measured the days. Okay, students, like that. And how which clocks they have used in the olden days means, so they have used some clocks like what are those? Sand clocks. I will show you. Where are those? Yeah, there are the sand clocks, water clocks, like that clocks they have used, and they have used pendulum clocks also to measure the time trends. So the working of clocks is rather complex. So those are the things they have used. So what are those? By seeing sunrise, sunset, by seeing moon, and by seeing shadows of a moon and sun, like that. And by after that by sand clocks, water clocks, by pendulum. So this is the upgradation process, students. In that way they have grown, they have observed the universe, observed the surroundings, and they have used it to measure the time. They will not know the exact time like that, by using a digital clock. By using digital clock you will know exact hour, exact minute, even though you will know exact second also. But in that olden days they don't know exact hours, exact minutes, exact seconds, but they will know that that time is around 3 to 4 hours, or around it is going to sunset, or it is going to sunrise, or like that only. They will know the approximate values only, students. So after that clocks have developed, students. So that clocks have pendulum clocks, they are working on that pendulum. After that watches has upgraded, clocks has updated, students. So the working of clocks is rather complex. So basically how clocks work is something rather, students, but all of them make use of some periodic motions. So but what is the thing is they use periodic motions. So one of the most well-known periodic motion is the simple pendulum. So they use the how clocks are working is they are using the principle of periodic motion. So one of the most familiar thing is the simple pendulum. It makes it is a periodic motion. Suppose if you see the pendulum, or if you see the dial like this in a clocks, it will move there and it will move there. So it will make a periodic oscillations, periodic motion. So that is the simple pendulum, students. Okay. You can also make a simple pendulum, and you can find the simple pendulum oscillations, and even though you can find the time taken for one oscillation. Suppose take a long string or that, and take some small ball, iron ball, or any ball like that. So we call metallic ball. So we call that metallic ball as the bob of the pendulum. Take some string like that, students. And what you have to do is so what happens, you have to just move this bob, suppose if this is the position, you have to just move like this and leave it. What happens, you have to just tilt it to some distance and leave it. What happens whenever you're moving this tilt and leaving, it will goes like this, and it will goes like this, it will move. So these are the these are the oscillations, periodic oscillations. So this is called a simple pendulum motion, students. So it begins to move to and fro. So the to and fro motion of a simple pendulum is an example of periodic or an oscillatory motion. So the to and fro, from here it is going to that point, and from that point it is coming. It is going to that point, from that point, to that point, from that point, to that point, from that point. So the to and fro motion is called as periodic motion or a oscillatory motion, students. So the pendulum is said to have completed one oscillation. So whenever we say that one oscillation is completed means, so suppose it starts at this point, and it has moved this and come to each this, then we say that it has completed one oscillation. So suppose I will draw here, students. So this is the pendulum. So this is the mean position. So it has started here, it has started here, it has entered here, again it has come here. So it does not go that much. It has come there, it has go towards it, it has come towards there, and it has come towards it. So whenever it comes to again its mean position, we call one oscillation. So we can measure one oscillation by another way also. Suppose this at this position. So it has started here, it has entered there, like that, and it has coming to this point. So in that case also we say that is one oscillation. So what is the another thing? Suppose it is at this place, it has gone there and it has come at this to the position. So whenever it returns to its original position, after completing all distance, we say that it is completed one oscillation. These are the examples of one oscillation. Okay, students. So the time taken to make one oscillation is called the time period of pendulum. What is the time period means? Time period means time taken for one oscillation, one complete oscillation. So this is called complete oscillation. So this is called time period, students. So what is one oscillation? We know. Suppose it is started from mean position, it has moved there and has moved again there, and it has reached to this point. So this is one complete oscillation. So the time taken for movement from this point to this point coming to this point is called the time period. Okay, students. So by doing a simple experiment, by doing this, you can find the time period, students. What you have to do is just tilt this, and what you have to do is you have to need a stopwatch. Okay, students, and you have to just tilt it and leave it, and you have to measure how many oscillations it is making. So you have to measure 20, you have to observe the 20 oscillations. How many oscillations? 20 complete oscillations. 20 complete oscillations, and you have to, after counting the 20 complete oscillations, after counting, so this is the thing, you have to tilt it and you have to leave it. So from this point, whenever it starts here, whenever you are leaving it, it will goes like that, it will comes like that. So this is one complete oscillation. Like that, you have count for 20 oscillations. After that, you have to find the how much time it has taken for 20 oscillations. So here time taken for 20 oscillations. So whenever you have counted the 20 oscillations and the time taken for 20 oscillations, suppose it takes 42 seconds to complete the 20 oscillations, then dividing that 42 by simply 20 seconds, this is the 42 seconds, this is the 20 seconds, you will get the time period. What it is? Time period or time taken for one complete oscillation. How much time it takes to complete one oscillation. So that value you will get by measuring the time for 20 oscillations and dividing that time with 20 seconds. So how much it is? That is almost about 2.1 seconds. So for one complete oscillation, it will take 2.1 seconds, friends. So that is the thing. This is the thing, students. This is the time period. So note that all slight change in the initial displacement does not affect the time period of your pendulum, students. Nowadays, most clocks or watches have an electric circuits with one or more cells. So nowadays, our advanced watches are having electric circuits. So these clocks are called quartz clocks. So we call these nowadays clocks are quartz clocks. Quartz clocks, they are having electric circuits. The time measured by quartz clocks is much more accurate than that by clocks available earlier. So nowadays we are using quartz clocks, they're having electric circuits inside it. Clocks, they are having electric circuits. The time has more accuracy, so they will give much more correct value of the time using quartz clocks than olden clocks. So that's it, students. That is about the time, how to measure time. So now we will going to find out the units of time. So before going to find out the units of time and speed, I am going to ask you one question. So you will buy milk, is it? Yes. How you will measure the milk? Sir, we will buy packets of milk, sir. We will buy 1 packet or 2 packets like that. Then how much quantity is that packet? So otherwise, do a simple activity. So go to a shop and ask for milk. Ask for a milk packet. Then they will surely ask you how much quantity milk packet you want. Whether you want the half-liter packet or 200 ml packet or 1 liter packet. So by doing that activity, you came to know that we will measure milk. We will measure milk in liters. So now simply ask for rice. Then whenever you are asking for rice, what they will ask you again? How much quantity you require? Whether you require 1 kilogram, whether you require 2 kilograms, whether you require 3 kilograms, whether you may ask rice or sugar. They will ask these questions. So by that you will know that we will measure rice or sugar in kilograms or kgs, half kg, quarter kg, which means not quarter kg, is meaningless, half kg or 250 grams, like 1 kilogram. 1 kilogram is how much? That is 1000 grams. Or like 1000 grams or 500 grams, how much quantity you want, like that. So we will measure the milk in terms of liters. So what is the unit of? So from this, what is the unit of milk? Unit of milk is nothing but liters. What it is? Liters. So unit of rice or sugar is kilograms. So in this way, so we are going to find out the unit of time and units of speed, students. So how, in which quantity or in which way, with using which we are going to measure the time. So basically what are the units of time is? Now we will measure the time. The basic unit is seconds. We will represent it with yes. So this is second is the basic unit of time. So basically what are the other units? That is minutes and hours. Will represent hours by H, minutes by MIN, like that. Okay, shortcut form. So what are other units? Means days, months, years, also the units of time only. So whenever anybody asks you how old are you, then you will say my age around 11 years, sir. My age is around 10 years, sir. What is years they called? What is meant by years? Means it is the time. So almost 11 years of time has completed after coming to this world. Okay, students. So that years is also measure of time, students. So if anybody asks you the how old are you, then if you say, sir, it is 11 years. Instead of 11 years, if you say, sir, I have completed 11 into 365 days, sir. 11 into 365 days. So basically 1 year is having 365 days. No. So instead of telling 11 years, if you make 11 into 365 and you have find out the answer, how much it is, that is simply, it is very simple by if you write those. So 365, 5, 6 plus 5 is 11, 6 plus 3 is 9 plus 1, 10, that is 4. So sir, how old are you? Means my age is 4015 days, sir. Then they will laugh at you. Students. So while measuring or while telling the answer, we have to find out the what the situation is. So if anybody asks you age, you have to tell it in terms of years. You have to tell it years. Or if anybody asks you how much time it takes, how many days are there for your exams, then you have to tell in terms of days. Or if anybody asks you how much time it takes to complete your games on single day, you have to tell I will play for almost 1 hour or 2 hours. You have to tell in the terms of hours. So regarding the considering the situation, we have to use the units of time, students. Okay, and what are the units of speed, students? So basically we will use speed. Speed is nothing but distance by time. No, what are the units? So speed is nothing but distance by time. So what are the units for distance? They are kilometers, meters. So what are the units for time? That is hours or minutes or seconds. So what the units of speed means? That is whether kilometers per hour or whether meter per second. So these two are the units, meter per seconds or kilometer per seconds. Or how can we say means say kilometers per hour, kilometers per hour, or like that. Or we can say this is the kmph, kilometers per hour, meter per seconds, or m by s. Okay, students, in this way these are the units of speed, kilometers divided by hours. So we are calling divided by as the per, kilometers per hour. Whenever there is a slash or dividend, we can say it as the per, meter per seconds, kilometers per hour, like that, students. So this is the units for units of speed and units of time, students. Okay, I think you have understood it clearly, students. Okay, so many times measuring devices were used different parts of world before the pendulum clocks become popular, or sundials, water clocks, and sand clocks. So these are the used in the by our older generation, students. Okay, so different designs of devices have developed in different parts of world. So in the different parts of world, they have developed different designs for clocks, like sand clocks, water clocks, and sundials, like that, students. Okay, so one more thing you have to know is the pulse of a normal healthy adult at rest beats 72 times in a minute. So for the pulse of a normal healthy person is it will beats of 72 times in a minute. If you want to know it in seconds, it will beat 12 times in 10 seconds. In 10 seconds it will beat 12 times, or in the span of 1 minute it will beat 72 times, students. What it is, that is our pulse. And how long is 1 second time? If you want to know how long is 1 second time, is simply by your mouth, by you shouting loudly, by saying 2001. If you try to speak it 2001, so the time taken for you pronouncing 2001 is the time of 1 second, students. Okay, these are the one or two things you have to remember in your mind, students. That's it, students. We have completed third topic. So now we will start the fourth topic, students. What is the fourth topic? That is measuring speed. So we know how to measure the time. Now we know what are the units of time and speed. Now we are going to find out how to measure the speed, students. Okay, so now we will do some activity. So draw a straight line using a chalk or anything, and you ask your friend to take a stopwatch and note the time. So what you are doing, you are standing there and you are throwing a ball, and what your friend has to do, so he has to start the stopwatch whenever the ball just crosses this line, and you have to end the stopwatch whenever the ball comes to rest. And what you have to do is, finally by doing that, you will know the time by using stopwatch. By using the stopwatch, you will have measured the time from which to where, from whenever the ball has just crossed it to the whenever the ball comes to rest. The time between these two events, we have measured the time. using stopwatch. After that, by using a tape, you have to find the distance from the this wall this line to the point where the ball comes to rest. We have to measure the distance using a tape like that, and you have to find the time, measure time using a stop clock or stop clock watch. From where to where? These two incidents are from line to stopping ball to the ball where it has stopped, from line to the ball where it has stopped, students. Okay, this is the thing. So after that, whenever you have completed finding measuring distance and whenever you are completed measuring time, what you have to do, we have to divide both of those. So distance divided by time will gives you the speed of that ball, students. So you can simply find it speed. So one thing is, you have to mention the speed in the whether it is in kilometers per hour like that, or you have to mention it by using meters per seconds. So you have to if you are using the time, if you want to represent in meter per seconds, you have to measure the time in terms of seconds. And if you want to represent by meter per seconds, you have to measure the distance in terms of meters, friends. Okay, in that way you can easily find the speed. In the same way, if you want to know how much speed it takes for your travel from your home to school, means just find out the distance between your home and school and just measure the time how much it takes to goes from your school to home. So sorry, home to school or school to home. Then you can easily find out the dividing by both distance by time, you will easily find out the speed of you. Suppose if you are bicycling, so while bicycling, what is the speed of your bicycle? Suppose if you are walking, how much speed you are walking? So all this you can know by doing this simple formula, students. So this is the thing you can do by your own. Okay, students. So basically, draw a table like this, distance moved by the ball, you have to write like this, and time taken for it. So finally, dividing distance by time, you will get the speed, students. Okay. So basically, rockets, satellites like that, no, they will attain a speed of 8 kilometers per second. So which means they will cover the distance of 8 kilometers in the span of 1 second only. So that is the greatest time, students. And you will know the tortoise, it will attain the speed of 8 centimeters per second. So 1 second it will move just 8 centimeters. So these are the both extremes of the speed, students. Okay, so whenever you are knowing the speed and whenever you are knowing the time, then you can easily find out the distance traveled. Suppose if you know a bike or anything, you know it will move with a constant speed, you will know the speed of that bike, and you know how much time it has traveled. Then you can easily know the distance. That is, distance is nothing but speed into time. By multiplying speed and time, you will get distance, how much distance it is there. Suppose you have moved from point A to point B, or from school to house, or from any place to any place. So you know you have moved with some bike, you know the speed of the bike, and you know from this point to this point it takes around the time, that is 30 minutes or like that. So by multiplying speed with the time, you will get the distance between these 2 points, friends. So this is one more thing important for you. We can easily find the distance. So distance equal to speed into time, students. Okay, that's it, students. So basically, in the vehicles, what you will see 2 meters. One is speedometer. So this speedometer shows the speed, and there is odometer. So this will shows the distance covered, how much distance have traveled. So this will measures the distance, and speedometer will measures the speed, students. Okay. So this is the speedometer. So this is the area now. Kilometers is there. So this is the odometer. So this is odometer, and this is speedometer. This is speedometer. So by seeing this, you can say with how much speed you are moving. By seeing this, we can know how much distance you are moving, students. Okay, so that is the difference between speedometer and odometer. By using it, you can find the speed. By using it, you can find the distance traveled by you, students. Okay, so now that's it, students. That is the 4th topic. that is measuring speed. You have completed it. Okay students, now we will start the fifth topic. What is the fifth topic? That is distance time graphs. So what is the use of distance time graph, students? So now I am going to help you to know that, students. So basically what happened is, so there is a school picnic. So what happens, there is two persons. What are those? Who are those? Pehli and one other is Bajo. So Bojo. Okay, both are going to both all the schoolmates are along with the teachers. They are traveling neighbors to a school picnic. So Pehli decided to note the readings of the odometer. So what the odometer shows? Odometer shows the distance for every 30 minutes of time. So she decided to measure the time for every 30 meters, how much distance they have traveled. So she have noted all the information. So they have reached. Looking at the table, Bojo asked Pehli whether she can tell how far they would have traveled till 9:45 a.m. Pehli had no answer to the question, friends. So they have started their journey and they have ended their journey at 10 a.m. So they have started at 8 a.m. They reached the picnic spot at 10 a.m. students. So looking at the table, so here she has written the odometer reading, so that he has find out the distance from the starting point. So these are the odometer readings. By observing the odometer readings, she have written the distance from the starting point. So after that, seeing this table, what happens? Bojo has asked Pehli that at 9:45, you know the distance traveled by 9:30 a.m. and you know the distance traveled at 10 a.m. But what is the time? What is the distance traveled at 9:45 a.m.? So for this question, Pehli has no answer. Why? Because means she is having on this table of values, so she can tell what is the distance when the time is 9:30. She can tell what is the distance when the time is 10 a.m. She can tell what is the distance when the time is 9 a.m. But from the table, from seeing the table, she can't predicted the how much the distance when the time is 9:45 a.m. So then they will move to their teacher, and their teacher suggested them to draw a distance time graph. What it is? Distance time graph. So by using distance time graph, what her teacher told you that by using a distance time graph, we can usually know by using it at any point of time what is the distance traveled by us. That's information you can usually get by seeing the graph, but seeing the table we can't get it. So for that reason we have to require distance time graph, students. Now we will understand what graphs and what are the different types of graphs and how to draw a distance time graph, students. So basically we will represent so much of information in the graphs. So there are different types of graphs. This is bar graphs. Here the bar graph is for the runs scored per the overs. In how many overs, how many runs are scored for this is. And another graph is the bar graph. This is the pie chart. Okay students, pie chart of this pie chart is showing the composition of all gases in a air, and this is a line graph. What it is? A line graph. Okay, it is showing the weight of a man with ages. So these are the different graphs, students. Now we are going to know how to draw a distance time graph. For that, what you require? Distance time graph. For that we require a graph paper. We have to take a graph paper like this, students. So after taking graph paper, we have to draw two perpendiculars. One is xo x dash, which is horizontal, and you have to draw yo y dash, which is vertical. So the point of intersection of these two graphs, we call it as the O origin, friends. And we have from O on the xy towards the x, we have to mark the positive values, and from O to x dash we have to mark the negative values. From O to y we have to write the positive values, and from O to y dash we have to write the negative values. From O to x we have to write the positive values. From O to x dash you have to write the negative values, and you have to use this graph only, this shaded graph only, students, because the x values are positive and y values are positive here. Okay students, so after taking this graph, So basically, Bojjon Pehli, what they have done means they has a table of values of a motion of car. So this is the another values of tables. So what are the values, the table, what are the values on the table are, they have the time in minutes and they have the distance covered by that car. So in the 0 minutes it has covered 0 distance, and in the first minute it has covered one, after in the time interval of after 1 minute it has covered the 1 kilometer distance. After 2 minutes it has covered the 2 kilometers. After 3 minutes it has covered the 3 kilometers. So now we have to put this table into the graph. Okay students, so for that what we have to do is, first thing is we have to take the x part, y part only. So here positive x values, here positive y values students. So first thing, whenever we are taking the graph, after thing you have to draw two perpendiculars like that, ox and oy. This is the ox and this is the oy students. After that we have to, first step is perpendiculars, draw perpendiculars ox and oy. What is the next step? Choose which quantity on x-axis. Choose quantity on axis. So which quantity you have to measure, write in the x-axis, and which quantity you have to write in the y-axis. So basically we are taking the time in the x-axis and we are going to taking the distance in the y-axis students. After that you have to take the scale. How you will take the scale? If you see, there are the markings, there are small boxes here. How it looks like is, that is, there are boxes like that. So from here to here there will be distance of 1 centimeter. Here also 1 centimeter. In this direction also its length is also 1 centimeter. So how you have to take scale is, you have to write like that, on x-axis 1 centimeter equal to, so 1 centimeter, this is the 1 centimeter distance. So we have to take how much? 1 centimeter. Suppose if you take 1 centimeter on x-axis is 1 minute. So which means we are going to take the 1 minute of time for 1 centimeter distance. On y-axis, how we are going to take on y-axis? Suppose for 1 centimeter, how much amount you are taking? Suppose we are taking 1 kilometer per 1 centimeter students. Okay, like that you have to take the scale on the graph. So and you have to write the values like that. So here for 1 centimeter is 1 minute, 2 minutes, 3 minutes, 4 minutes, like that. Here it is 1 kilometer, 2 kilometers, 3 kilometers, 4 kilometers, like that. After that, after marking the scale, what we have to do? We have to look for the graph, or you have to look for the table. So what are the things here? For 0 time, the distance is 0. So time is where it is on the x-axis. So make that point, that is the 0, that is here. And what is the distance is how much? It is also 0. So we have to mark this point. And what is the time? Next thing is 1 minute. So where is 1 minute? 1 minute is here. So we have to draw a perpendicular at that point, which is parallel to the y-axis. So we have, suppose this is the graph. So this is the 1 minute. Now you have to draw a perpendicular at this point. Which is parallel to y-axis, like this. Okay students, so this line is the 1 minute line. So after that, what we have to do? We have written, you have drawn the minutes. Now we have to look for the distance. At how much distance? 1 kilometers. So we have to observe the 1 kilometers distance, that is around it 1 kilometer. So from this point also we have to draw perpendicular, which is parallel to x-axis. So like that. So you have drawn the distance line and you have drawn the timeline. So the two lines will intersect at one point. So we can remove this part. So this intersection point is having 1 minute time and 1 kilometer distance. Like that you have to draw for 2 minutes and 2 centimeters. Like that, if you plot all the points, all the set of points, if you join all the points, you will get a line, straight line. You will get a straight line students. So in the distance time graph, if you are getting a straight line, which means the motion of the car is uniform. So in distance time graph, if you are getting a straight line, which means the object or the car or anything moving object is in uniform motion. Object is in uniform motion. Object is in uniform motion, students. This is the thing you have to remember. Object is in uniform motion. For suppose for other graphs, for if it is not in uniform motion, you don't get a straight line, you will get some other curves like this, students. Okay, so this is the way of drawing a distance time graph. So I think I hope you have understand it. So now we will draw a graph for the this question. So where whenever the Bojo has asked what is the distance at 9:45 a.m. so he has to answer that question. So for that you have to draw a distance time graph. So what we know that you have to take it to perpendiculars, you have to take and you have to take scale. So taking scale is not that much simple, students. Suppose here what is the total distance traveled is almost about 80 kilometers. Suppose on y-axis you are taking the distance now. If you take 1 centimeter equal to 1 kilometer, then if you want 80 kilometers, it is at 80 centimeters. Then 80 centimeters is at 80 kilometers is at 80 centimeters. So it will take so much of long, but that graph paper is not that much of enough. Basically our graph paper is the size of 25 centimeters into 25 centimeters. So for that we have to change the scale. How you have to take for it? So the simple way you can take by it is you can take 1 centimeter equal to 5 kilometers. So for every 1 centimeter what happens? It almost 5 kilometers. So for 2 centimeters 10 kilometers. Like that your graph will be decreased. Okay, students. Otherwise if you want you can take 1 centimeter equal to 10 kilometers also. There is no restriction, students. Okay, that's it. If we are having 25 into 25 centimeters graph, the best thing is on y-axis 1 centimeter equal to 5 kilometers. On x-axis you can take 1 centimeter equal to 6 minutes. This suits for our data like this. For this data we are going to write like this, students. Okay, this is the best suit for our graph, students. Okay, so basically our journey has started. Their journey has started at 8 a.m. and by the time of 8:30 a.m. what is the distance traveled by them? So 8:30 a.m. they have traveled 20. After 9 it is 40. After to 9:30 it is 60. So you have to represent all those. So at 8:30 they have traveled 20, like that. You have to draw 20 perpendicular at 20 and you have to draw perpendicular at 8:30. So they both will intersect at a point. So that point is the distance. That point shows the distance and time, students. So by that you are able to draw all these points, students. Now if you want the distance at any particular time, suppose if you want the distance at 9:15 p.m. so this is the 9:15. suppose if you want the distance at 9:15, what you have to do? You have to draw a perpendicular at this point which is parallel to this point. And what you have to do is you have to draw a perpendicular which is parallel to distance axis, y-axis, like that. And whenever it is touching the or cutting or crossing this straight line at that point we have to draw a perpendicular to the distance axis or the y-axis which is parallel to this x-axis. So you have to draw a axis like that. So this perpendicular line will meet at a distance of some many points. Suppose it has reached the 50 kilometers, it has cut at a point of 50. So then you will say what is the distance at 9:15 a.m. is? That is 50 kilometers. That is 50 kilometers. So by simply doing this by graph you can easily find out. Suppose what is his question? 9:45 a.m. So for that we have to suppose this is 9:30 and this is 9:45 a.m. Okay, students. So draw a perpendicular to this line which is parallel to y-axis, and whenever it cuts whenever it cuts the axis, whenever it cuts the straight line, from that point we have to draw a perpendicular to this point. Okay students, perpendicular to that line y-axis, it will comes at this. Suppose it has cut it at 70 kilometers. So then what is the distance at 9:45 a.m.? That at 9:45 a.m. the distance is 70 kilometers students. What it is? 70 kilometers. So by using a distance time graph, we have simply find out the answer students. Okay. So at 9:45 a.m. the distance is 70 kilometers. At 10 a.m. the distance is 80 kilometers. That's it students. In this way you can easily find out the distance traveled by using a distance time graph students. Hope you have understand about the distance time graph students. Okay, so that's it students. We have completed our chapter. Our chapter is completed. Now we will start the summary of this whole chapter students. Summary. So without wasting time, we are going to have the summary. So motion and time is the present chapter. We are going to, it is having 5 topics. We are going to have the summary. So first topic is the slow or fast. So where some vehicles will move fast and some vehicles will move slow, and same vehicle move fast at some time, at that same vehicle move slow at some time. How we will decide which vehicle is moving fast or which vehicle is moving slow? Suppose if a time is fixed, if in a certain given interval of time, we can say which is moving faster, which is moving slow by considering distance. So if in the given interval of time, if time is fixed, which objects or which vehicles are covering large distances are moving fast, which are covering small distances are moving slow. And if another case, if suppose distance is fixed, if suppose 100 meters race is there, such that if distance is fixed, then in that case, how we will say which is moving faster, which is moving slow? In that cases, by considering time taken up for their travel, we can decide it. Suppose if any car or object is taking less time to cover that much of distance, it is moving fast. Suppose any car or vehicle is moving taking larger time or more time to carry that cover that distances, it is moving slow students. Okay, next thing is the next concept is the speed to students. Basically speed, how we will say speed is this is very simple. So which is covering the larger distances in given interval of time is moving, is having higher speed. Higher speed means nothing but having it is moving fast. So or which is covering the distance in less time is called as it is having high speed students. So basically we will represent, suppose there is 50 kilometers per hour, speed is 50 kilometers per hour, which means it is covering 50 kilometers distance in the span of 1 hour students. And how we will represent the speed is speed is nothing but the total distance by total time taken. Okay students, so that is the speed about students. Next thing is the measurement of time. So how we will measure the time? So basically in the present generations we are having table clocks, wall clocks, digital clocks like that, but in olden days they are used, our ancestors used sunrises, moon, shadows, sand clocks, water clocks, pendulum clocks like that to measure the time students. Okay, so by using a pendulum also you can measure the time. So this ball, metallic ball, we call as the bob, and the to and fro motion of this simple pendulum we called as the oscillatory motion. The time taken to complete one oscillation is the time period. Okay students, one oscillation. Next thing, by knowing by finding the time taken for 20 oscillations and dividing the time by 20 seconds, you will get the time period of a simple pendulum students. And what are the units of time and speed? We will measure time in terms of what are the seconds, minutes, hours students. We will measure the speed in terms of kilometers per hour or meter per second students. So basically quartz clocks, nowadays our present clocks are quartz clocks, they are having electric circuits and they have shows the more accurate time students. So that is about the third topic students. We have completed it students. Okay, and our pulse makes 27 times, beats 27 times in a minute students. That is one thing. So how long is 1 second time is? To shout loudly 2001, that time is the 1 second students. Okay, next thing is the fourth topic, which is measuring speed. How you will measure the speed students? So basically by finding the distance and finding the time between 2 points, you will get the speed between the 2 points students. We will measure it by kilometers per hour or by meter per second students. Okay, and rockets are having the highest speed of almost 8 kilometers per second, and tortoise is having lowest speed of almost 8 centimeters per second, students. So by knowing the speed and time, you can find out distance also, students. If you want the distance between 2 points, if you know the speed of the vehicle that is moving from that point to that point, and is the time taken by that point, by that vehicle to reach from that point to that point, but speed into time equal to distance, students. So basically vehicles having odometer, it shows the distance traveled, and vehicles having the speedometer, which shows the how much speed they are going, students. Okay, and now we are coming into the distance diagrams. What are the distance diagrams uses? By seeing the table, we can't predict some values or can't predict some things but we are by having the distance diagrams, we can get more information. So how to draw distance diagram is basically take a graph and you have to draw two perpendiculars, and you have to use the first region, and from first region we have to take the which quantity, select which quantity on x-axis and which quantity on y-axis. After that you have to select the scale, students. So after that you have to mark the points. So if you want to mark 1 minute, you have to draw perpendicular at that point which is parallel to y-axis, and if you want 1 kilometer, then you have to draw perpendicular at that point which is parallel to x-axis, students. So the intersection point will give the both time and distance of that point, students. By joining all the points on the table, you will get a straight line, students. So this is the method of drawing distance time graph. So in this distance time graph, if you are having a straight line, then it is a uniform motion, students. So in distance time graph, how you will get the find the distance at any point of time is, so simply you have to first decide at which point of time you want the distance. At that point of time, you have to draw a perpendicular to the x-axis which is parallel to the y-axis, so that it will cut the curve or straight line. So at the intersection point of the curve with the straight line, we have to draw another perpendicular to the y-axis which is parallel to the x-axis. This perpendicular reaches any of the point on the y-axis. That reading on the y-axis gives the distance, students. In this way, you can easily find out the distance of at any particular interval of time, students. So that's it, students. Our chapter is completed. Our summary is also completed. Have a nice day. Hope you are good. All are doing good. So please do subscribe our channel. We are doing so much of hard work to get free education for all of you. So we are creating videos on all chapters, on all subjects from class 6 to class 12. So please do subscribe our channel. Also like and share our videos. Have a nice day, guys. Bye bye.